Okay guys, so we're giving you a Delta Math assignment, and on the Delta Math assignment, I know that there are show examples and there's also the help videos that are there for every question. So, but I just wanted to go through a few more examples of these with you guys, walking you through kind of slowly. So let's take a look at this example here, because this kind of includes everything you learned with the product and quotient and also incorporating the negative exponents. So we have x to the negative fifth times x to the fourth all over x to the negative fourth. So I want to take a look at how we would go about simplifying this. So if we take a look in the numerator, there we're multiplying same bases. So when we multiply same bases, we have to add our exponents together. So if we add negative 5 plus 4, that's going to give us in the numerator x to the negative first over x to the negative fourth. So now that we've gone from this to this, now we're dividing same bases. And when we divide same bases, we have to subtract the exponents. So this becomes x to the negative first minus negative 4. So if we do negative 1 minus negative 4, we end up getting x to the third power. So that is going to end up being your final answer. Let's take a look at this example here. So we have x to the seventh over x to the sixth, y to the eighth, and y to the negative sixth. Now in this case, if we look at the numerator, there's nothing to simplify at this point in the numerator. So we're just going to rewrite x to the seventh. But in our denominator, we have y's that we're multiplying together. So in that case, we can add the exponents. So here we end up with x to the sixth we keep. This here becomes y, and then we add 8 plus negative 6. So 8 plus negative 6 gives us y to the second. But we're not done simplifying yet, because if we look this way, we're dividing same bases, so we have to subtract those exponents. So if we do 7 minus 6, we get x to the first. So our final answer, if we get rid of 6 x's here and 6 x's here, we're left with that x in the numerator, our x to the first, over our denominator is y to the second. So that would be your simplified answer. I'll give you a second to look at that. All right, so one more final one that we'll take a look at. X to the negative eighth times x to the eighth all over x to the fourth. So if we look in the numerator, here we're multiplying same bases, so we want to add our exponents. So that gives us negative 8 plus 8, which is x to the 0 over x to the fourth. So if you look at this, x to the 0 power, anything to the 0 power is always equal to 1 over x to the fourth. And again, 0 minus 4 would give us x to the negative fourth if we did it that way, and x to the negative fourth is still equal to 1 over x to the fourth. So either way, you get that same exact answer. All right, so let's look at this type of example. This is going to be on there as well. So here we have 5x to the negative second. Now this here, because there are not parentheses around it, if there were parentheses, everything in the parentheses would be raised to the negative second power. But because there are no parentheses, this says 5 times whatever x is to the negative second power. So they're separate. So this is the same as doing 5 over 1 times 1 over x to the second. All we did was put this over 1 because it's a whole number. X to the negative second becomes 1 over x to the second because we make it the reciprocal and the exponent positive. Now we multiply straight across. 5 times 1 is 5. 1 times x to the second is x to the second. So that's going to be your final answer, 5 over x to the second. All right, and we'll look at an example with parentheses so you can see the difference. So here we have negative 4x to the negative second. So here there were no parentheses, so just the x was being raised to that negative second power. But here, because there are parentheses, that's telling us that everything in here has to be raised to that power. So we write the reciprocal of it, 1 over negative 4x to the second power, and our exponent becomes positive. But here, we're not completely simplified yet. So this, remember, your exponent rules. So this is to a power, so a product to a power. So we're doing negative 4 to the second power. So negative 4 times negative 4 is positive 16. And then we have x to the second power is just going to give us x to the second power, is how you're going to do that type of problem. Okay, and I'm going to do one more type of problem with you, and then hopefully you should be good between my video and the Delta Math videos. So here we have 5x to the fourth over 3x to the fourth to the second. So the first thing that we want to do, there's nothing to simplify in our numerator. So we look down in our denominator, and here we can do this power to a power. So this is going to give us 5x to the fourth over 3x to the eighth. 4 times 2 is going to be 8. Now, if we look here, we're dividing same bases. So we can subtract the exponents. So 4 minus 8 is going to be negative 4. But it's going to go in the denominator and be a positive exponent. Because again, if you think about it, we can get rid of 4 of these x's and 4 of these x's, and we're left with the 4 x's down on the bottom. So we get 5 over 3x to the fourth for that final answer for that one. All right, so my work today is kind of all over the place, so this is driving me nuts. So I know it's probably driving you guys nuts as well. So let me kind of box all of this off so you can kind of see the separate things there. All right, so these are the types of problems that you're going to see in your Delta Math. And again, you have those examples to look at, so utilize those, and you also have the help videos for each of the questions, so you can utilize those as well.